joining in a little bit later, but just to do a few introductions, I'm Shelley Mullins. I'm the CAD/CAM specialist out of the Kansas City branch. And with us today is Shelley McMahon with On Pharma, and also our guest speaker, Dr. Butterman. Little background on Dr. Butterman. He graduated with honors from the University of Maryland. He has graduated from the Misch Institute, International Implant Institute.
I made up the by the way, if I'm being honest with no.
He's been very involved with the now the CDocs and his resident faculty with CDocs. And is currently in practice in Colorado and runs his own practice and also continues to, like I said, be a resident faculty with the cdocs.com. So I appreciate everyone getting up early and joining us this morning. I think it's going to be super informative, and you're going to be able to learn a lot about how to maximize your efficiency with CEREC. And he'll have a lot of tricks of the trade, so to speak, to help you become more efficient in your office. So without further ado, I'll turn it over to you, Dr. Butterman.
Thank you, Shelley. Thank you both, Shelley. Thanks to Patterson Dental for inviting me, and On Pharma for also inviting me as well. Some of you might not have heard of this company, so I'll talk a little bit later about them as well. But I'm really excited to be here. This is really fun, and it's probably the best part about it is that it probably will, at least for the next hour, take all our minds off of counting votes, which has just been absolutely insane. And that's all I'll say about that. Thank you very much for the introduction, Shelley. The big thing with me is that I kind of live and breathe CEREC. I have a private practice in Denver. I am a beta tester for Zirconia. So I'm generally on multiple software versions. I beta test software, hardware, materials. So I kind of insight in all the stuff coming down the pipeline. I know the problems that you guys have. I know the problems that you guys are going to have. And I also know a lot of the workarounds to some of the issues based on what I do. I also do a lot of the implant side of things with Zirconia implants. I work a lot with surgical guides and a lot of those different workflows as well. But I'm also really excited, and I want to kind of embarrass her for a second, because you have a fantastic resource. It was really kind of sucks for me because my right hand, my former dental assistant, Danny Huntsman, just recently moved out to your area. And she probably knows at least, if not more about this stuff than I do. So I just want you to know that I've done a lot of programs with a lot of really intelligent doctors. I've been on the speaker circuit. I worked with all the faculty at CDocs, and I can tell you quite honestly, probably the most intelligent person I've ever met in dentistry is not a dentist, it's Danny. So she's just a fantastic resource, and I'm not exaggerating at all. So I hope you guys can take down her email address, and if you need her for anything, whether it's for yourselves or for assistance, just know that she's in your area, which I hope you'll take advantage of, because I've always tried to take advantage of Danny. Wait, come out, right?
Thank you, Dr. Butterman.
So I want to start, and this is really a CEREC efficiency lecture, and I'm going to handle it. I'm going to jump in from a couple different approaches here, so that hopefully I can share a couple things that'll be valuable for you. Efficiency really does start with the team. So that's why, from my perspective, having assistants involved and really having Danny in my practice was just so huge for me, because it just let me do so many things that I didn't really understand before. So I want to handle it from an efficiency, understanding staffing. I also want to handle it from a software efficiency. How do we go through all of the steps? And then I really want to look at just some cases and go through some ways so that we can really deal with some of the frustration that I know a lot of you run into. So let's start with just a typical CEREC appointment. A breakdown of an appointment for me, these are all the things listed on the left that have to happen. Patients butt in the chair until they're writing a check out front. These things have to happen in order for the patient to leave with a crown. So we've got to seat them, we've got to anesthetize them, we've got to prep their tooth, we've got to do some imaging, we've got to design, we've got to manufacture the restoration, and we got to glue it in. So how long do these things typically take? As I may or may not have mentioned, I teach the level 2, formerly level 2 course at CDocs. So if you're in Charlotte or you're in Scottsdale and you take this course, now it's called Fundamentals of CEREC Dentistry, then you'll get a lot more of this stuff from me. If you absolutely hate my presentation, then maybe don't go, but otherwise you'll see a lot more of this stuff. But a typical breakdown for most of it, and I think a lot of us would agree that a crown appointment handled in about 90 minutes is good. That's where we're generally shooting for. And I want to show you ways to get to 90 minutes. And really, I also want to show you ways to get past that, to be quicker and more efficient than a 90-minute crown. Because now we're kind of pushing the envelope with some changes in our workflows. We're kind of getting down to that 60 to 70-minute time range for any of the materials. So if we look at this slot of time, the one thing that I want to point out, because I talked about assistance and utilizing staffing, what are the parts of the procedures that I have to do? And what are the parts of the procedures that I can turn over? So if I look at this typical 90-minute appointment, the first 10, 20, and maybe 30 minutes, I'm busy. That is an appointment where I need to be with the patient. I'm numbing them up, I'm prepping the tooth, and I'm doing some imaging. The middle part of the appointment, I don't need to be there. The middle part of the appointment, if I can delegate this, I now have my team being able to design the restoration, mill it, manufacture it, stain and glaze, whatever needs to happen. And then I need to be back at the end to bond it into place. So my front office understands that when we schedule a crown appointment for a patient, I'm actually going to see them for 2 visits. Now they happen to be in that same 90-minute block of time, but I'm going to see them twice. So I will see them at the beginning of the appointment. I'll see them at the end of the appointment. But the middle block of time, I can do anything else. There's nothing else I can do for that patient because I've delegated that part. I could be doing another crown. I could be placing an implant, any of the other procedures that I like to do. So a lot of you, and I used to be this way before Danny came into my practice, I used to be the guy that said, hey, I know this better than everybody else. I'm gonna not delegate this. There's no way my team members can do this as well as me. And I was doing pretty good. I would spend about 30 minutes doing the prep stuff. I would spend about 30 minutes doing the design and manufacture, the stain and glaze, and then we put the restoration in. So I was going about that 90-minute workflow, but I was all in for that 90 minutes. Now if on average you're charging somewhere around $1,200 a crown, that's still pretty good production. That you're still producing about $800 an hour. But if you're willing to delegate, and even if you're willing to slow down and say, okay, well, forget the 90 minutes. Maybe my assistant is kind of newer at this and it's going to take a little bit longer. And maybe it's going to take you 40 minutes to prep, and it's going to take more like 40 minutes for the design and manufacture and then to bond. The point is, once you've now delegated and freed up that 40-minute block of time, it allows you to do other things, and your production will skyrocket with that. So if you're not utilizing your team for that, please learn how to do that. Please take advantage of that, because that will be the biggest factor in you being much, much more productive if you can just delegate that middle part and do another procedure during it. It's mind-blowing how much more efficient you are. And for those of you that say, I can't get my team to do this, there's no way I can train them to do this, it's absolutely not true. Team members love this kind of stuff. And I would say that Danny and my other assistant Bree would fight over the CEREC cases, because it's just, they're doing more than sucking spit all day. It makes them feel as if they're a valuable part of the team, which they are. And I think that they take a ton of satisfaction and pride in being able to do these procedures. So trust your team, train your team, and they most likely won't let you down unless they do what Danny did and leave my practice and move away. So let's take a look at these numbers again for just a second. If we look at a couple of them, so we can get more efficient by getting better, by getting faster, by becoming more knowledgeable, but sometimes we can get more efficient just because of changes in technology. So if we look at that, what used to be a 10-minute block of time for our anesthetic, and we look at what we always used to believe was a 30 to 40-minute window to design and manufacture a crown, what if just because of technology, we could shrink that? What if we can change our anesthetic time down to 2 minutes instead of 10? And what if we can change our manufacture time down to 25 minutes or less? That would just automatically slice 20 minutes off our entire procedure. Now we have a 90-minute procedure that we just turned to 70 minutes simply because we made a couple of changes. Is that big in your practice? is an extra 20 minutes for every CEREC procedure going to be something that makes you more productive? Is that helpful for you? And I know who I'm talking to. You guys, you take an adhesive that has to be scrubbed onto a tooth for 20 seconds, and there's no way in hell you guys are going to sit there for 20 seconds. So when somebody says, hey, it's not 20 seconds, it's now 5 seconds, you're all in. I'm not talking seconds here. I'm talking 20 minutes. And I think a lot of us will agree that that's huge. So how do we do that? One way is simple. One way is a change in anesthetic. And I think we've looked at our workflows, and because of COVID, because we understand now that we're trying to keep things a little bit safer, we're trying to be with one patient at a time, we would ideally, it's not great to put on all our PPE, numb the patient, and then take it all off, leave, go somewhere else, and then come back and put it all on again. It's just so much easier to numb the patient and stay there. And that's why I've become a huge, huge fan of buffered anesthetic. So for those of you not using it, if we're given a traditional block, the biggest issue that we have with any anesthetic is that it's acidic. So the acidic nature is necessary in order to preserve it so it lasts. But because of the acidity, you've got pain on injection, you've got delayed onset, and you've got an unpredictable result. So what has to happen when you give a patient a shot? A couple things have to happen. It comes in an anesthetic form, but in order for it to be useful, in order for it to actually cross into the nerve membrane, it has to go from an acid to a base. The patient has to basically neutralize that anesthetic. So we've got to rely on their chemistry. We've got to rely on the patient's ability to buffer that anesthetic before it can actually do anything. But if we do that for them, if we buffer or neutralize that anesthetic by adding sodium bicarbonate to it, now we've got 6,000 times more free base that we can have available to cross the barrier. I just want to very briefly just show you the system that I'm using in my office. This is an Onset pen, and it's super easy to use. Basically, it's this pen, and you just take your cartridge of anesthetic, and you just plug it in. And then you have a dial that shows how much of the sodium bicarbonate is going to fill into the anesthetic, and the equal amount of anesthetic would be pulled out of the cartridge. So you push a button, it takes about 1 to 2 seconds, and it just pre-mixes it. You can use any anesthetic that you like in your office. And once you buffer that anesthetic, you're good to go. So, and the way that it works is basically as soon as you neutralize it, now you're not waiting for that anesthetic to have to cross that barrier. It's going to do it immediately. So what it's done in my office is basically taken my block procedures that I used to do and cut it from about 10 minutes down to 2 minutes. When I infiltrate, basically I pick up the handpiece and go. So there's basically no waiting. It's really changed everything. It's shocking because the anesthetic time used to just be a big pain in the butt, and waiting for that to happen, this isn't a thing. So Shelly is on from Refinement. If you have questions, you can just type it on the chat message. If you want information, just put your information on there and she can reach out to you. If you haven't looked at it, I would strongly encourage you to do so. And it's just something that automatically will shave about 8 minutes off of every procedure that you do. Let's talk a little bit about materials and some of the workflows. So resilient ceramics, composite resin blocks, a lot of people aren't really utilizing that much. And I kind of want to throw this out there because we're talking about efficiency. This could be a very efficient block. Now, to be clear, I don't use any of the resilient ceramic blocks for full coverage crowns. These are too flexible, and in my opinion, not just mine, but from what we've seen, we have problems with debonding if you're using these type of composite blocks as a full coverage crown. They're just too flexible and they can debond. But for partial coverage, these things are fantastic. Doing inlays. If we're doing a whole quadrant of composites, how much fun is this for you and your patients? And my understanding in where you guys are, you're pretty much all in when you do a quadrant of composites. You're not really turning this over to your team members to do this, most of you guys. And that patient's going to be there for maybe hour and a half. And at the end of it, your back's going to be killing you. And it's not a great practice builder when we're putting wedges and bands and patients are hemorrhaging all over the place when we do this. So for me, my preference is generally I'm going to prep it, scan it, and leave. And then an assistant like Danny would then very quickly design each one of these restorations. these things mill out really quickly. If we're using a hybrid block, they mill out in maybe 5 to 7 minutes per restoration. And these don't go into an oven, so they're polish only. And then once those are designed and done, Danny just calls me back into the room and I bond those into place. So the patient might still be there for that hour and a half window of time, but the point is I'm not. I'm there in the beginning to prep and I'm there back at the end to bond. So it becomes like that crown appointment, and it becomes something where I can be much more efficient and utilize my time elsewhere if I'm willing to delegate these procedures. And I don't just use them for inlays. I do a lot more onlays. I never used to do onlays before CEREC, but that's really become sort of a great thing, because now we can very quickly go through and we don't have to take the whole tooth down. We can remove broken parts of the tooth. We can remove old restorative material, and then we can quickly manufacture and mill out just out of a hybrid block, something that's going to fit really well. Take off the sprue. We can do just a little bit of light cured stain and glaze to it. And now in about an hour, we've got a great restoration that's ready to go in. A couple things with inlays and onlays that I want to make sure that you guys are clear with. Number one, just because we're using a composite material doesn't mean, oh, it's bad, I shouldn't charge full fee for this. In my practice, I charge exactly the same for an onlay or a crown. It's exactly the same. And I often don't know which procedure I'm going to do when I start with a patient. And that's sort of the reason why I charge the same, because if my fee was different, then I would have to stop and have a conversation with my patient. And I don't really love talking to my patients that much. So if my fee's the same, they don't care if I save a cusp or not. I'm just going to prep what the tooth gives me. And this becomes an incredibly efficient appointment. Couple things to keep in mind with this. If you're doing an onlay type of a prep, undercuts are bad. Undercuts are going to cause problem. We know in the software that if you do a restoration for a crown, the software is going to do a really good job of blocking out undercuts, but it doesn't do quite as well with blocking out undercuts in onlays. And I just want to show you what I mean. So we don't want to get fancy with this. We want to really just get a nice smooth prep. It's important that if you're prepping your tooth and you take your handpiece, as you get to the occlusal cavulous surface, we don't want to take that handpiece and we don't want to lean it into the prep. We want to have a 90-degree butt joint if possible, because as that restoration meets the occlusal cavulous surface, it thins out. And that's one of the main reasons why I like using hybrid blocks, is because if I use glass, if I use Empress or Emax or one of the glass materials, and it gets thin, it's going to chip, it's going to break. And when the patient comes back on recall, we're going to have open margins where material is broken away. If we use a hybrid block, a resin material, and again, this is a fully polymerized material, so we're not getting shrinkage like we do in regular composites, it's going to tend to want to wear on that surface and not chip and break away. Let me just show you what I mean. I'm going to kind of jump back and forth on software here, but I kind of want to show you what I mean with the inlays and onlays. Let me just create a new patient here. I'm just going to hop on here. I just want to take a second to do this. Let's just add a new patient real quick. And for some of you that are new to CEREC, you'll be able to see what this looks like. We'll call the patient Patterson and their first name Onset. That's like really weird, but I guess that makes sort of sense since these guys asked me to be here. But we'll just create this patient and we'll add a new case. Let's do this as a single restoration. We'll call it biogeneric individual, and I'm going to choose number 14 because I just want to show you guys on the type of what I'm talking about with the onlay. So let me get a quick scan. I'm using a prime scan for this. The idea would be very, very similar for you guys if you're using your Omnicam. But I just want to show you what I'm talking about because this is super important. If you guys are going to start doing onlays or get really good with them, we have to understand this concept. So let me just get a quick scan here. And for those of you that are not using the prime scan, one of the cool features of the prime scan is that we have artifact removal, meaning that if I get something in the way, like my disgusting thumb, the software is going to look at it and say, hey, that doesn't belong there, and it'll just take it away for me. So really, really nice feature of the prime scan. We'll just fill in all of this area. Okay. I'm not going to bother with the opposing the buckle bite here, but I just want to make you guys aware of this concept here. So this prep is perfect, mainly because I didn't do it. If I did it, it certainly wouldn't be as perfect as that. But the prep is perfect, but we're going to screw it up so I can sort of make this point. The idea of removing undercuts in the software has been there for a long time, and each version of the software gets better and better, and it does a really good job, as I mentioned, with crowns, but far less so with the with inlays and onlays. So we'll just let this come up. Okay, I'm just going to go ahead and screw up my prep. Let's hit our edit model. And so here we see my onlay prep. And we have no undercuts in here, but under edit model, maybe some of you guys didn't even know this was a thing. You can go to your tools, you can go to form, and you can go to remove. We'll just make that a little bit smaller, and we'll create some artificial. Maybe we had some decay here, so we removed a little bit of decay on one surface. And we'll try another surface here. Do you guys know you can edit your models? You can actually artificially extract teeth as well, and do all kinds of stuff under the edit model. So if you haven't looked at that, that's really a cool thing to see here. So let's go ahead and we'll just set our model axis. Something like that, and we'll get our proposal. Sorry, we're getting a weird glare on my screen. I know it's probably kind of bugging you guys a little bit, and I know you can't see actually. I know you can't see actually the text on here because the Zoom meeting compresses it. But let's just go ahead and draw our margin. So you can see how we've created those undercuts in the model, and those are there. Those are things that the software should block out, but it's not going to do such a great job, or it may, we'll see. Sometimes it gets better and better. We'll draw our margin, and let's go ahead and just get our proposal. Okay, here's our proposal. Let's take a look at it. If we can orient this model in the way that we want to view and slice it, we can now go to our Analyze tools, and we can go to something called Slice, and we can make our way through the restoration. So let's make that a little bit bigger. And here you can see one of those undercuts. I'll just back up a little bit here as I'm walking through. You can see one of those undercuts, and the software didn't actually drop the restoration all the way in, but you can see it came in a little bit. So that part of that restoration actually dropped into my undercut, and now there's no way that's going to be able to clear that occlusal surface. So don't rely on the software to be able to remove these. You need to be able to come through and make sure that they don't exist. And here, that second one, you just see that it just didn't do a great job of that. So just keep that in mind with your onlay preparations. Let's switch back here. What if we're doing crowns and root canals? If you have a patient that's scheduled for both a root canal and a crown, we want to consider switching up our workflow. I think most of us would say, hey, if I'm doing a root canal and a crown, I'm going to do the root canal first, and then when I'm done with the root canal, I'll do a buildup, and then I'll do my crown prep, and we'll move on from there. That's really not the most efficient way to do this. We want to change that order. So when a patient comes into my practice and they need a root canal and a crown, the very first thing I'm going to do is clean out all the decay. Even if I open it into the pulp chamber, I'll put a little Teflon if I need to. I'll build the tooth back up, and then I'll prep it for a crown. And then from here, I'm just going to take my CEREC, and I'm just going to push it off to Danny. And she is, well, not Danny anymore, but somebody that's nowhere near as good as Danny. And she will go ahead and design that restoration. and do all of the crown stuff. While she's doing that, I'm just going to take my other assistant and I'm going to cut an occlusal access opening through the top of my prep, and then I do the root canal. And then we have this sort of friendly competition where I'm doing the root canal while the crown's being made. But the point is, by the time I'm done treating the root canal, that crown's already ready to go. And then my assistant's just going to be able to hand it to me, and I'll be able to bond that in. So simply switching that workflow, changing the order, is something that can save an enormous amount of time and just allow you to be much more efficient. I'm not watching the chat here, so I don't know if there's any questions that have come up that we want to stop and answer here. Anything, Shelley, that we need to address right off?
No, I think we're good right now. So keep on going.
I want to point out this study to you guys, because the question that comes out with new users and people that have been doing this for quite a while, one of the questions that comes out is, how good do the restorations fit? How accurate are the margins? And this was a really cool study. A good friend of mine, Dennis Fassbinder in Michigan, participated in this study. And what they did was they made these models, and I'll kind of get out of the way just a little bit here as I fall out of my chair. They made these models, and it had a crown, it had inlay, it had onlay, and they sent them to dentists with not much CEREC experience. They sent them to assistants with no experience, and then they sent them to Empress certified, so really high-end labs that knew how to do this stuff. And they said, I want you to make a restoration for each of these, and then they were going to cut them up, and they were going to see who did the better job making the restorations. And the really, really interesting part of this is that, yeah, I mean, the dental assistants did a little bit better. It's probably not statistically significant. But the point of this is all of them, whether they were experienced or not, were able to get incredibly great fitting restorations, better fitting than any sort of a lab process restoration, which is somewhere around 100 microns to 120 open. These were in the 60 to 70 range for how open these margins were. So why was everybody able to get such a good result? And the answer to this is that the software is very consistent. The software is going to follow the same algorithms. The milling machine is going to follow the same path. It's going to do its thing every single time. And you will 100% of the time get a very, very consistent result. Now, that result is either consistently good or it's consistently bad. It all comes down to the prep. And so I want to spend some time talking about the prep, because we need to understand that. That's where you fall off the wagon. And the reason all of these fit so well was that Dennis prepped all these teeth, and he gave a perfect prep. So of course the restorations were going to be perfect every time. So what are we looking for in the prep? We want to have glassy, smooth margins. We want to have rounded internal surface, and we want to have separation between the adjacent teeth. If we have these things, and if we have enough reduction, and I want to harp on that for the next half hour that I'm with you guys, if we have enough reduction, we're going to have success. Again, another prep, if we take time to polish this, if we take time to smooth everything out, everything else gets easier. If you take shortcuts here, if you don't have a great prep to work off of, then everything else goes downhill. And there's nothing, the design process that I want to show you should take 3 to 5 minutes maximum. If you have a bad prep, it now bumped it up to maybe 10 or 15 minutes because you're trying to overcome prep issues. So we want to spend the bulk of our time on our prep. I want you to understand a couple concepts. One of them is called overmilling. And don't worry that I'm blocking the words, I'll talk to you about that. What basically overmilling means, if I leave some sharp anatomy, if I have a cusp of my tooth or a regular rough surface, doesn't have to just be on the occlusal surface, but if I leave it rough, then we have to understand the diameter of the burr. The milling machine burr for glass ceramics, the diameter is about 1.35 millimeters. So if I leave anatomy that is skinnier than 1.35 millimeters, the milling machine has two choices. It can either say, well, I can't fit in there, so I'm not going to go there. That's called veneer mode. You have a milling mode on your machine called veneer mode. And that's specifically designed to not create any sort of overmilling. But that wouldn't be really helpful for our crowns, because if it doesn't go in there and mill it out because it can't fit, then your crown's not going to see. So what the normal milling mode means is that the burr is going to come through and it's going to overmill. It's going to say, I can't fit in there, so I'm just going to have to take away some extra porcelain. You know it happened if you look up underneath your restoration and you can see those little circular areas. That's where the burr came in and it did that overmilling. Well, what's that going to do for you? You might say, hey, well, I know I prepped my tooth enough. I know I had enough reduction, but if you leave it rough, If you leave surfaces where the burr can't fit into, now all of a sudden it's going to have to overmill. So your porcelain potentially gets much thinner than you thought. So it's really crazy. You can have 1.5 millimeters reduction in a smooth surface and get a proposal with no glue and it looks great. Or you could have 1.5 millimeters reduction and now it's glue, minimal thickness issues all over the place because you left it rough and there was a lot of overmilling. So please keep that in the back of your mind when you're prepping the tooth. Smooth matters. So again, just looking at it from another end, those circular areas above me in the crown, that's where that burr came in. And it had to hog out that whole area to get it to fit. If we use veneer mode, then it's not going to go there. The burr is going to say, well, I can't fit there. And it's super helpful for veneers because sometimes our veneers are only 0.5 millimeter thick. So we wouldn't want it to do that over milling because it potentially could punch through the veneer. So we're really just going to leave veneer mode for veneers. Crowns, we want to make sure that we're not using this milling mode. Same thing happens in the margin. And this is super, super important for you guys to understand. If you leave an irregular surface, if you leave a bump or a ridge on the margin, then the software is going to do exactly the same thing. It's going to say, hey, I can't fit in there, but if I don't fit in there, then the restoration is not going to go down. The whole restoration is going to get hung up. So I'm going to go in and hog out that area. So any area around the margin that you leave with anatomy thinner than 1.35 millimeters is going to be overmilled and you will be guaranteed to have an open margin there. So we want to spend enough time, we want to polish, we want to get a nice smooth surface. So how do you know that you reduce the tooth enough? I get calls and I get questions from people all the time. They say, hey, I know I reduced my tooth enough and I'm still getting minimal thickness issues. What the heck's going on here? There's something really weird with the software. And when I say, well, how do you know you reduced your tooth enough? Then they say, well, and this is how I used to do it. They say, well, I had the patient bite down and we kind of take a look and yeah, I can see that I reduced enough. Well, that's kind of BS. We are experts at reducing buccal cusps, but there's no way we could have enough perception to be able to see the central fossa and the lingual or palatal cusp. There's no way that we can actually visualize that. So first burr I use for every restoration is a depth cut. I'm going to take a burr, and I'll show you more about this in a second using it. I'm going to take this burr and I'm going to seat it as deep as it goes, and I'm going to move it mesial, distal, buccal, lingual, and that's going to guarantee me that I have enough reduction. Now, if I want to end up with a glass ceramic restoration that is going to be 1.5 millimeters thick, then I need to reduce 2 millimeters of tooth. If I want to end up with a zirconia restoration that is going to be 1 millimeter thick, then I need to reduce 1.5 millimeters. So I have two depth burrs. I have one that reduces 2 millimeters and one that reduces 1.5, depending if I'm doing zirconia or glass ceramics. Why the extra 0.5 millimeter? Well, again, you're going to get some overmilling, you're going to have some spacer, and then the anatomy needs to be nice and deep. We don't want flat, worn out anatomy. We want nice, deep anatomy that the software will kind of give us. So we need that extra 0.5 millimeter for those things to happen and not have a minimal thickness issue. So here's what it looks like. We just take that burr and we're just going to seat that burr in, and we're just going to push until it doesn't go anymore. That's going to limit our depth. And a lot of you are like, oh my God, a 2 millimeter burr, if I take that 2 millimeter burr and sink it all the way in, then blood's going to start shooting out of the patient's head and they're going to need a root canal. It's going to be horrible. If you take that burr and you push and till it doesn't go anymore and you look, almost always you're just going to still see more restorative material. We don't create pulpal issues from an occlusal reduction aspect. Where we create it is from an axial reduction. That's where that pulp comes much further out, especially as we start dropping subgingival or equigingival. So from an occlusal perspective, don't worry about reducing 2 millimeters. You're going to be fine. Your patients are going to be fine. So that's number one. Then we have to come through and we're just connecting the dots. So we're just going to take off all of those depth cuts, those orientation grooves that we just created. And doesn't matter the burr that we're using, but we're just going to connect all of those dots. And then we have now made sure that we've reduced enough. Now we've got enough reduction for the type of material that we're using. When we come to our interproximal reduction, I'm going to use just a more slender burr. So I'm just going to come through and we'll open up that interproximal. I'm typically using a CAD/CAM specific burr, whether it's a Brasseler or typically I'm using Meisinger. I love the Meisinger burrs. Meisinger makes these fantastic kits that are specific to CAD/CAM, and that's going to basically be matched machine-wise to the milling burrs. So you're going to create a similar shape. that the milling machine can create. So I would encourage you, if you don't have CAD/CAM specific burrs, that you at least look at those. And then we're going to come through with our axial reduction. The trick with axial reduction is that you want to use whatever you're in your practice, whether it's a coarse burr, extra coarse burr, or medium, you're going to use your most coarse burr that you like to use in your practice. Typically, I'm going to use about a millimeter diameter burr to be able to do this. So that's going to create my initial shape, but you need to understand you're not done. Once you come through with that coarse burr, it's critical that you refine that margin. And here's kind of the magic is that now we're going to take a red stripe diamond. So my preference is either to do the exact same burr that you just use in coarse and do fine, or even better yet, do just slightly bigger diameter. Because what we sometimes do when we're prepping is if we take that burr and we seat it all the way in axially, we can kind of create that sort of a J shape to the margin. And if you come back with a burr that's a slightly larger diameter, or if you come back with a round burr, or you come back with a stone, then you'll be able to take that lift that you accidentally created. But this step is critical. If you're not smoothing and you're not refining your margins, then you're not going to have the accuracy in the fit. And the way I personally like to do it is I do this on a low speed or an electric, just turn it way down and I turn the water off. The water's so reflective that sometimes I can't see that irregular surface. When I'm going really slow and dry, I can really make sure that I polish that margin. That extra step is going to be huge. And we're all taught in dental school that if you touch the adjacent tooth, you're going to hell. It turns out that's not true. And a lot of us will get tunnel vision. When you prep a tooth, you focus just on your tooth and you ignore everything around you. And then you go to build your contacts and you're saying, well, I really like blue with a little bit of green on my contacts. And then you start doing your smooth tool and it's just jumping, it's going to red and it's disappearing because you're trying to build it to an irregular surface. The last thing I do before I image is I'm going to use a soft flex disc and I'm just going to polish those surfaces. And that will give you that nice broad flat contact to be able to build to. Really, really critical step in your prep. So the takeaway from this is that if you have a predictable prep and you're following a recipe, you don't need a ton of burrs to do this. If you're following a recipe for it, you're going to get a predictable margin that's drawn automatically for you. You're going to get a very easy, predictable design. The result is going to be predictable. And again, it's either going to be predictably bad or predictably good. And there's no two ways about it. If you are giving rough preps, not enough reduction, not smooth margins, you will 100% of the time get a milled result that is predictably bad. So please understand that it's not that the prep is bad, because a lab process restoration is different than a CAD/CAM process one. It is a bad prep for this technology or for this milling machine. So we want to make sure that we're giving the machine what it needs. It's not that it's necessarily not an appropriate prep in general for this technology. It might be though. I want to talk about one parameter, and then I'm going to jump on the machine here because I'm quickly running out of time. Occlusal milling offset. A lot of people forget that this number is there. It's just one of the parameters. It used to be in the main parameters. Let me get out of the way a bit here. In the manufacture phase, there is a number called occlusal offset. You will never see it with zirconia. This is only there with glass ceramics. I want you to set it to -175, -175, and forget it. Never change it for anything. It's not something, and this was a very misunderstood number, so I want to just explain what it means for you guys. The reason it exists, from talking to the engineers, and I do talk to them almost every day, the reason it exists is that the harder materials, the glass ceramic materials, there was always a certain amount of error. So the burr would hit the hard materials, the burr would flex a little bit, the motors on the milling machine would flex a little bit, the block would flex a little bit. And what was happening was it was creating inaccuracies. So when you look at your design and you go through and you measure your minimal thickness and you measure your fissure thickness and you're looking at everything, that's the target. What was happening is that when we would actually mill out a restoration, the milled restoration was slightly larger than our design. So the -175 is basically reducing the crown in all dimensions to bring it back to your actual design. So you don't need to compensate. You don't need to say, hey, because of my -175, my crown has to be a little bit thicker in my design. No, don't even worry. Don't even think about it, because all it's doing, that -175, is bringing you back to your actual design and allowing your target to be correct. So let's just run through quickly. And I know some of you that are more experienced have been through this and understand the design sequence of FOCC. But I just want to jump on the machine here and just show you a couple things with that. Let me switch back over. Let's just go to our start screen here. And we'll add a case here. So I'm just going to do a crown on this typodont on number 30 really quickly. Doesn't matter the material, we'll just call it Emax here, and we'll go through and we'll do our acquisition. One of the things we don't want to ever do, whether it's a CEREC OmniCam or whether it is a prime scan, is we don't want to do a lot of over imaging. It will actually cause the margin to be less clear. So look at the pace that I'm scanning. I'm moving relatively quickly. I'm getting the critical information. I'm doing a crown on 30. I have the margin. I have the adjacent contacts. I'm done. Scanning just needs to be that quick. We don't need to go over and over the same area once we have it. Same thing with the upper. We're just going to quickly get an image. Do I need to fill in all the holes on the lingual surface if I'm doing a lower crown? Absolutely not. We just need the critical areas, which are going to be the occlusal and the buccal surface of the teeth. And then we'll do our bites. When we're doing our bite, we just need a couple teeth that are common between top and bottom. It doesn't need to be, the prep doesn't even need to be in there. It could be anything here. Sorry, I've got a green screen behind me and I can see a little bit of show through of that, which is annoying the heck out of me. So I'm just going to make one adjustment while that's coming up. Oh, that's a little better, not much. Okay, so the software is now trying to draw the margin. And again, the automatic margin finder, it doesn't know what a margin is. It's just looking for a ledge. So if you've given it a good ledge, it will attempt to find it. It doesn't always find it. It will sometimes drop off. So in the new version of the software that we're using, this is 5.1.2. That's the latest version of the software that all of you should be on. It's a good version of the software. It's a stable one. If it does a bad job doing the auto margin like it did here, and this is something that it should have been able to find, I'm just going to go ahead and trash it and reset it instead of manually coming back and redrawing that. And now it's going to switch again. Now it's called magnetic margin instead of auto. I'm just going to, and one thing I want to just show you, I don't have to be crazy accurate on my margin. I can be a little bit off. And here you'll notice that I'm starting with that red dot and I'm a little bit off of my margin. The software is going to be able to say, hey, there's no ledge here. I'm going to come back to and find it. But let me just show you what that looks like. We'll just go halfway around. And I want you to watch when I click here in a second, I want you to watch what that red dot does. Can you see how it jumped to the margin now? So the software is going to try, it's going to say, hey, idiot, there's no ledge there. I'll move it to where there's a ledge. So you don't have to be that crazy and be that on there. The software is looking for it. But the automatic margin finder, it only takes seconds to draw a margin like this if you've prepped and you've polished and you create a proper ledge. So if you're equigingival, subgingival, you're going to have more challenges with this. Let's go through our design. So the formula that I'm going to use for my design is something called FOCC. FOCC means, I'm just going to shut all of this off. FOCC means that I'm going to stay in the same order every single time when I'm designing my restoration. I'm going to use the least amount of tools as I possibly can to design this. And in a second, I'm going to bring up another case where FOCC doesn't work because it doesn't work every single time. So we need to use another tool called positioning, which is basically my get out of jail card free. that I want to make sure you guys understand. So if I'm going to go through FOCC, F, the first letter stands for fissure thickness. So if we look at our cursor details, we can see that this is 1.07. We chose Emax for it. Maybe we want to conventionally cement it and we want it to be 1.5. So we're going to open our tools and we're going to use our shape and our anatomical. And all I'm going to do is grab my entire restoration and move it up a little bit and let go. And now we're closer. We're at 1.45. I know you guys can't read these numbers. And then instead of grabbing my entire restoration, I'm just going to grab the fissure area and we'll bring all of that up as well. So now I've created some high spots on my restoration, but my fissure thickness, it's more than thick enough. I'm at 1.82. So if we say, okay, I like that, I'm at 1.82, that's great. So now we can go through and we want to fix our occlusion. Couple different ways to fix the occlusion. Option number one, and I know my head's in the way, is to click on occlusal adjust contacts. So I can click on adjust contacts. And then if I hit on occlusal, the software is going to automatically lower that for me based on what my parameters are. So that's one way to do that. Sometimes when you do that, it drops the fissure height a lot. Here, when I did it, it's 1.82. When I actually do it, you can see it dropped it down to 1.78. So I only dropped it a little bit, but sometimes it can, because it uses sort of a shotgun approach to take down the whole occlusion, it can sometimes overdo it. So if you want finer control with that, another way to adjust the occlusion is to just go under your display objects, put on your opposing arch. And now, just like we adjust the contacts where we can look at the contacts from underneath, we will look at the occlusal marks through the model. As long as your model is fully opaque, it will allow you to use your tool, and anything that is heavier than light blue will be able to be adjusted. Anything that is light blue or less will not be adjusted. So now I can go to my form and my remove tool, and I can just go through and just take away any of these spots that are showing through. And if I take away my upper jaw, we can see that we've very quickly gotten the exact same occlusion and we haven't changed our fissure height at all. So I use my occlusal contact button first, but if it drops my fissure height too much, then I reset it, and then I put my opposing arch on, use my remove tool, and take that away from through the model. So that was our F and our O. Next, we're going to adjust our contours. So contours mean, do we need to close any of our embrasures? So here it looks like on the distal, I'd like to close this area just a little bit on the distal lingual. So I'll go to my circular tool and we'll just grab that area and drag it out a little bit. If I don't need to do it on my adjacent tooth, I don't do it. Everything looks good there. So we just did F for our fissure thickness. Then we did O for adjusting our occlusion. Then we did C for our contours. And then last is contacts. I always like to adjust my contacts through the model. And let me show you why. Let's take away the lower jaw. Whenever we adjust our contacts, we want to use the form and smooth tool. So if I do this manually and I just come over, it's very easy for me to accidentally overdo it. So I can say, okay, well, I like blue with a little bit of green. Well, that looks good, but I've accidentally reduced a lot of that light blue area. I don't want just a pinpoint contact. So let's reset that. If I do it through the model, then just like the opposing arch, the model is going to block me out, and it's only going to let me take away areas that are green or heavier. So I'm not actually making any changes to any of that light blue. So when I take away the lower jaw, I haven't affected accidentally any of that light blue. If I come in manually and do it, I might remove some of that light blue and end up with a pinpoint instead of a broad contact. So we'll do the same thing from the other side. And we are ready to go. And then we hit mill. So that's the formula that I want to use every single day. That's my go-to formula, and it's something that is going to be predictable with all my designs. But the prep has to be there, and everything needs to be good for that. So let me just bring up another case here. Any questions while I'm bringing that up, Shelley, on FOCC?
No, we don't have anything yet, but please
like-
feel free if there's something specific that you're struggling with or you have questions that you
gonna
need
try some of this.
clarification
Oh,
in the
yeah.
software, please feel free to jump on chat.
Yeah, so feel free to ask out, guys. If you're not asking questions, it means that either I'm showing you stuff that is way over your head, or it's really obvious and stupid and I shouldn't be showing it to you, or you're fast asleep. And any of those are okay. But please feel free to reach out here.
Dr. Butterman, we did have one question. What is the recommended fissure height?
Depends on the material. So if we are using Emax and we want to conventionally cement it, it needs to be 1.5. If we're using Emax and we're willing to bond it, then it can be as thin as a millimeter. Any of the glass rims, the safe number is 1.5. Everything could be 1.5 and be successful. Some of the zirconias, and if I have time, I'll jump onto some of the zirconias. Some of the zirconias can be as thin as 0.8 millimeters for the fissure height. So again, it depends on the material that you're using for that. The software knows it. It's built into the parameters, and the software will give you a minimal thickness bubble showing through based on the material you selected. So let's just take a look at this case. I'm just going to go back to model here. And I'm just going to get a new proposal.
While you're getting that new proposal, another question came in. When you adjust your contacts through the model, it will only reduce the green or heavier areas, not the entirety of the restoration.
Exactly correct. So the model will actually act as a block and it won't allow the tool to work, and anything heavier, green or heavier, will be reduced as long as the model is fully opaque. If you make it translucent like this, then that trick doesn't work. So the model has to be fully opaque for it to work. So here's a design. So if we look at this crown on number 18, that looks like a piece of crap to me, if I'm just being completely honest with you guys. If we do FOCC for this, it's still going to look bad. It's just going to be thick enough and the contacts are going to be strong enough. So if we start with something like this, then we're going to run into, it's just not going to help us. So this would be something where I would use positioning. First thing I know is that for Emax, I didn't reduce enough because the software gave us this area of red. It only gives you high areas if it can't, it's trying at all costs, it wants to give you enough material thickness. So first step is let's go back and just change our material. Emax wasn't a good choice here, or actually I had Katana here, so that wasn't a good choice. Let's change it to a different zirconia. Let's change it to 3M chairside zirconia, because that doesn't need to be a millimeter, that could be 0.8. And we can now see our design really hasn't changed, but I can tell the software, hey, I changed materials. Let's go ahead and get a new design. I don't really need it to have all of that red. So I'm just going to say, well, with this new material, go ahead and just recalculate. So I'm going to hit recalculate and apply here. And the software is just going to give me a brand new material because now it knows it's 3M zirconia and not Katana. And lo and behold, we no longer have a high spot. Our restoration still is ugly. It still is not something that I would want to put in the patient's mouth. So now we're going to use something called positioning. If I click on positioning, the software is going to say, okay, here was where I thought you wanted the starting point. And this lets me actually go through and edit it and change my starting point. So I can tell the software, no, I would like this rotated just a little bit, and I would like it to be taller. Something like that. And then I can use my scale tools and I can say I'd like it to come further out to the buccal and a little bit further out to the lingual as well. And I still have a minimal thickness bubble showing through, so let's make it just a little bit taller still. So I tell the software, I know it's like turning red everywhere and you guys are freaking out and saying, oh my God, that's horrible. It's okay. It's okay. I'm telling the software that's my starting point. I now have two choices. I can either leave constrained adoption checked, or I can uncheck it. So if I leave it checked, I'm going to tell the software, here's what I want you to try and do, but I want you to take my opposing tooth into account and my adjacent tooth into account when you get my proposal. And if we go ahead and edit the restoration, it'll be a little bit better. That's where it's starting to try and go, but now it's got to look at my occlusion, and so it's going to shrink it way down to try and not give me high spots. It's better though. It's not quite as flat. My marginal ridge is much higher. We have a much, much better looking proposal. simply because we gave it a new starting point. So again, that was positioning, and then I positioned my tooth exactly where I wanted it. If I don't get a good result, and actually that was a nice result, I probably would have left that and then just gone through my FOCC with it. I can uncheck constrained adoption. And now I can say, when I say I want it here, I mean I want it here. I want you to give me the restoration exactly like that. The software is going to say, okay, fine, it's going to be high, but that's what you wanted. That's what you got. It's not the end of the world. I have nice anatomy. I have the cusps the way I want it. I have the marginal ridge the way I want it. How do I fix it? Same thing I showed you before. Just go through to the contacts, hit occlusal, and we're here. Any area that over-reduced, you can see how it used that shotgun approach. My fissure height dropped to 0.64. So now I can just come through and just with my shape and my circular tool, we can just fix up those couple thin spots. Remember, this is chair-side zirconia. Chair-side zirconia can be 0.8 millimeters thick. And once I've achieved that, which I have here, I'm at 0.84. Now I'm all good. So just a couple different ways. And now remember my original starting point, it just didn't have any anatomy. It was just a flat blob. FOCC wouldn't help you with that.
Dan, if I could interrupt for just a minute, could you go back again and show them how to make the model opaque or clear? And then I do have another question for you after that as well.
Absolutely. So if I want to do my contacts, and let's just drag this, make my contacts heavy. If I want to do my contacts through the model, my model has to be fully opaque. So if I'm using my form and my smooth tool, what's happening, can you guys see? I know the video quality isn't great. You can see a hand, that means the tool is going to work here. But when I actually get on the model, it's just a cursor. It just rotates my model. It does nothing. It blocks it out. But if I go to my lower jaw and there's a slider and I make that translucent even a little bit, now the tool works everywhere. The model doesn't block anything out. So it's important that if I want to use that trick, that my model is fully opaque. Next question.
So lately, if I don't trim the images closely, when I move to the margin phase, the margin ends up going around the unprepped adjacent tooth. So now I've wasted a lot of time in the imaging phase trying to create a very clean image, meaning no fingers or soft tissue.
Yeah, so I'm going to interrupt you. The margin goes, there's something called trust but verify in the software. So trust but verify is the set model access step. Is an automatic step, but it sometimes isn't going to be correct. So if you ever see the software draw a margin around the wrong tooth, it means that it did a bad job positioning your model in the correct orientation. It means that maybe it positioned it like that, and then it drew it. So if you get something that's weird or funky, whether it's a proposal, a margin, a copy line, go back and check this step. I promise you that's where the software made a mistake. If you reposition your model in the right place, it says, oh, okay, now I get it. Now I know where tooth number 18 is, and reset the margin, let it redraw it, and it'll give you a correct margin.
Thank you.
Okay, in my last 1 minute, I just want to show you one last thing. I wish I had like 2 days, which I normally have 2 days with you guys in Scottsdale or Charlotte. I mentioned about saving time with anesthetic, but another way to save time is with zirconia. So in my practice, I use a ton of zirconia and I love it. And one of the reasons that I like it is because the fit is so ridiculously good. So if we're looking at the milling machine burrs, the burr on the upper left, that 1.35 diameter burr, that's the one that's going to be used to mill the internal of my glass ceramics. Look at the burr just beneath it, that tiny little burr, that's what's going to be milling my zirconia detail. Which one is going to be able to get finer detail, less over milling? All day long, that skinny burr is going to be able to create better anatomy, and then it's going to shrink 25% approximately. So all that detail gets even finer. For those of you that have looked at or not looked at, the prime mill is insanely good with zirconia. When it rolled out, I beta tested this. I've had this for about almost 2 years now. So I've been working through all the same battles and struggles and broken burrs and weird software crap. And unfortunately, when it got launched, It happened right when the whole world fell apart and none of the engineers were allowed to work in Germany. So a lot of these issues got left behind. But I can tell you now that any of these issues with prime mill have been addressed, and it is insanely, insanely good now. As of 5.12 software, everything has basically been fixed, and it's just a great platform. But there's something called super fast mill. So I was talking about getting the time of my restoration when I manufacture my restoration down. Here's how super fast mill works. If we use Katana, for example, and I like Katana, it's a Carrari Noritake product. I think aesthetically, it's almost as good as Emax, not quite. But if we're using super fast milling with this, we can run this through the prime mill. And if you just look at our mill times, fine mill with zirconia is about 1830. Fast mill in the prime mill is 4 minutes. I mean, 4 minutes to mill out a zirconia crown. Extra fine mill, if we look, is a little bit longer. But I'm using super fast for all of my zirconia restorations. And the way it works is basically something called parallel milling. And what that means is that instead of with the MCXL, the way it used to be is the burr would mill the external, the occlusal surface, and then it would stop, and then it would come around and mill the internal surface. This is able to do both at the same time. It's able to parallel mill, and that's where it saves that huge, huge amount of time. So if we're able to mill this in about 4 minutes, and then we can fire Katana, all Katana fires at 18 minutes, now we're at 22 minutes. So we used to be in the 30 to 35 minute time frame for processing. Now we just cut our zirconia restorations down to about 22 minutes. So the combination simply, if you're not changing anything else, but just improving your anesthetic speed because of a buffered anesthetic and improving your milling time with super fast milling. And it depends how important. Maybe you don't care that it takes 2 hours for a crown, and maybe the time isn't important. But for me, that is important. And these numbers make a big difference for me to be more productive. So I am fastly approaching my end here. There's so much more I wish I could talk to you. I'll just leave this up here and we'll answer any last second questions. Again, if you want to reach out to me, please email me. I'm happy to speak to you guys. Again, if you take any of the our CDocs courses, you will likely see me. I'll be in Scottsdale and Charlotte. All our courses are going live. And again, you have a fantastic local resource, Danny, that she'll be happy if you need her to come into your office and either train you or your assistants with any of the stuff. She's available to do that. So reach out to her. What last second questions?
I don't think we have any, Dr. Butterman. I think that kind of winds it up. I would just really encourage all of you that have traded up and have been able to take advantage of the clinical accelerators. They have extended that for Scottsdale and Charlotte through the end of 2022, but they are actively holding classes in those locations now. So I know they're filling up fast, and if you are interested at all, it's better to start planning now and be able to participate in those. So I just want to thank you, Dr. Butterman, and for all the participants on the call today. You provided us with some great information and insight into some tricks of the trade, which I know you all can use. And again, to Shelley, thank you for Onset. And it's great to be able to share about the buffering and how that can impact the amount of time that it takes to get that person anesthetized. So
there was one more question, Dr. Butterman. Your burrs for prepping between Brasseler, where do you get your burrs at?
Yeah, so Brasseler makes they've got a CAD/CAM kit. It's a winter kit, which I really like. It's for CAD/CAM prep. And then Meisinger, probably I prefer Meisinger just a little bit. They have CAD/CAM specific kits. So call either your Brasseler rep or your Meisinger rep, and they will hook you up with any of the CAD/CAM. And get one full CAD/CAM tip for posterior and anterior. Find the burrs that you like in it. You don't need all of them, and then you'll just reorder just those burrs that you like, and you'll have luck with that.
And if anyone wants more information on Onset or buffering in general, you can leave some information in the chat. We do have a website with some lead forms, so if you're interested, you can take that route too. But we're happy to answer any questions you may have on that.
And if anybody wants to just try Onset with the patient, I can bring my kit in and would be happy to let you try it out on a patient in the office too.
I would not let Shelley give you an injection, just saying out.
Not the injection, just gonna
Oh,
buffer.
okay.
I'll let you do that.
All right, well, thank you. I know it was a shotgun approach. I apologize if it's a bit rushed. It's just, there's so much stuff I would love to tell you in hours, just nowhere near it long enough to even share a bit of it. But there are so many more things that we can talk about, and I hope that I will have that opportunity with you guys. Thank you very much, and enjoy the rest of your day and your weekend, guys.
All right. Thank you, Dr. Butterman. Thank you, Shelley. Have a
you.
great day.